Hello, scholars, and welcome to Lesson 1, Session 2 on understanding of rigid transformations and their properties. Just a reminder as you go through this that at any time, if you want to pause and try it on your own or come back to a section, you are in full control of that. Please do remember this is for you to help you understand exactly what you need to do for this lesson. It is all to help you understand. So please don't move on until you understand the ideas that we're presenting here. Also, remember, really important about watching instructional videos. Anything that I write down, you need to write down as well. You're welcome to write down additional things, but if I write it down, you write it down as well. Second thing is listening is really important, okay? You cannot have anything going on in the background. Don't be tempted to listen to music. There will be times when you can do that. Now is definitely not the time. Active listening is so important because what I say is oftentimes a lot more important than what we're going to write down. So please give me your full attention for this. Okay, so let's dive into it. We're talking about transformations some more. So this says figure PQRSTU, and that's how we often identify figures, is using letters that represent the points of that figure. So this figure is transformed to figure A, B, C, D, E, F. It's right here. So we're starting here on this red shape and we're ending up here on this blue shape. It says, is figure PQRSTU a translation, reflection, or rotation? Explain your reasoning. Okay, so let's think about that. And you all should have gotten some parchment paper, correct? And I actually, unfortunately, didn't bring any of the fancy stuff home, so I've got some of this that I found in the kitchen, but this should work. So if we take our parchment paper and set it on top of this, we should be able to sketch our shape that we start with, this red one, pretty easy. So why don't you give that a go as well with me? Let's sketch this image or this pre-image onto our paper. Now, this piece of parchment paper should make this pretty easy to tell if this is a translation, reflection, or rotation. Because if it's a translation, we know that that's simply moving it. If it's a rotation, we are going to be spinning. And if it's a reflection, we're going to flip that parchment paper over, okay? So as long as we take time and understand what these three words are, we should not have too much difficulty figuring out what is happening. So I notice if I move it, like that didn't work at all, okay? Because I can't turn it and stuff when I move it. Or it's not going to be a translation. So I have to simply move it, and that's definitely not right. So what are my other choices? I could rotate it, but I see that at no time when I rotate it does it match up correctly. Okay, so let's try a reflection then. And a reflection is a flip. We're flipping it over. It should match up nice and perfectly, and we see that it does. So we can tell without a doubt that this thing is a reflection. Because the shape has been flipped over. I'm going to double underline that word flipped because that's exactly what we're looking for, right? Okay, so it gives us some additional directions here. It says draw an arrow to show how the figure has been moved and add a center of rotation or a line of reflection. So we're adding a line of reflection here. This is how we flipped it. And this line of reflection is important because every dot should be exactly the same distance from this line of reflection now. And you'll notice that it is. Okay, so that also helps us tell that it's a reflection. See, 3 away, 3 away, 1 away, 1 away. Okay, so we've got this line of reflection, and we're oh, I should have drawn it this way, actually. We are flipping it over here. Flipping it over here. Okay, let's continue. So this says, when figures are the same shape, you can identify corresponding parts between the figures. Angles in the same relative position are called corresponding angles. Sides in the same relative position are called corresponding sides. Okay, so when you name figures that are the same shape, use vertex labels. So these corner labels with these letters. Okay, let's do this. So figure PQRSTU is the image of figure ABCDEF. Identify the corresponding sides. Okay. Oh, and I looked at this wrong earlier. This is going this way. This is going this way. We are starting over here and going over here. Silly me. Okay, I just read that thing wrong. So the figure is the red one. This is our pre-image. So identify the corresponding sides. This says side AB is the same as what on the image? Okay, well, side AB is right here. And it's obviously been flipped over, and now it is PQ. They better be the same size and in the same area, right? So I add this line to say that we're talking about a line here. Okay, how about this? UP. So UP right here was FA or AF, same thing. Okay, EF, and you can do this without me now once you understand. EF is the same as TU. BC is the same as QR. Make sure you're looking on each of these. RS is the same as CD. ST is the same as DE. Okay, how do the lengths of the corresponding sides compare? They are all the same measure. They are all the same size. They're all the same length. Their measurements are the same, and that's really important. And we know this because we can count them, right? This was 1, 2, and this is 1, 2. This is 1, 2, 3, 4, 5, 6, 7. This is 1, 2, 3, 4, 5, 6, 7. Okay, the lengths have not changed. We can prove it. This says in figure ABCDEF, side AB is parallel to FE. Side AB is parallel to FE. Agreed. So we can use this notation as well. So we're learning some notation. This is telling us that we're looking at a line. This is telling me that they are parallel. Similarly, the same sides are still parallel. How can we tell? Well, we could say that the distance between the lines never changes. The distance between the lines never changes. Okay, finally, our last little thing here. Look at the other pairs of parallel sides in figure ABCDEF. What do you notice about the corresponding pairs of side in figure PTQRSTU? We are going to say they are still parallel because we have changed nothing about the image to pre-image to image, other than we have changed its position and its orientation, how it looks to us. Okay, as I grab the next paper and you look at your next sheet, a quick random fact for you. Did you know that a woodpecker's tongue is so long that it wraps its tongue around its brain to protect itself from brain damage when it's pecking a tree? That is your cool random fact of the day. Let's continue. Try these two problems. Okay, so these figures over here all started with this blue shape. They all started with this blue shape. We need to identify each image as a translation, reflection, or rotation. Now, I bet some of you can look and see. For the rest of us, we might want to grab our piece of parchment paper and make this blue image. I always start by looking for a translation first. A translation. I should just be able to move this paper without spinning or rotate or flipping it. And look at that. I moved it straight over here and I found this. So let's note that over here. We are going to say HIJKL is a translation. Translation. I put my line across at the wrong spot. Oops. Translation. Okay. Which one's been rotated? Well, let's look. I think I see it already. If I spin this around like this, we are now on top of A, B, C, D, E. So we are going to say A, B, C, D, E is a rotation. And now let's make sure the last one is a reflection. And it looks like if we flip it like this, it is in fact going to be a reflection. Okay, so let's say that. We are going to say that P, Q, R, S, T is a reflection. Okay, so now we're going to talk about angles, and this should be pretty easy because none of the angles are changing, right? We're doing rigid transformations. So angle V, if we start with that, well, where did angle V end up? If you need to use your parchment paper, you can. You just label this as V. Label this as V up here, and we can move it. V became, and we're looking at figure P, so this one down here, this reflection. Okay, so it became, well, it's down here now, right? And that makes sense. It's now P. So we are going to say is the same as angle P. If you want to continue to use your paper, feel free. I'm just going to eyeball it now. Okay, so how about S? S was right here. Well, it should be equal distance from our line of reflection here. So it looks like angle Y is where we started. Angle Z right here will flip over and it is angle T. Okay, so we're looking for that same corner, okay? Make sure you're not looking for the bottom left, but where it flipped to. Angle X. Now that looks like it's angle R. And angle Q. That looks like it's angle Y or W. Okay, how do the measures of the corresponding angles compare? They are unchanged. They are the same angle measurements because these are rigid transformations. Okay. I think that we've done enough with this. Okay. The big idea is that the side lengths and the angle measurements do not change when we do a rigid transformation. That is a translation, reflection, or rotation. Just a reminder, make sure you get all the way to the end of the video before stopping, or you will not get credit for it, okay? Thanks for listening, and you should know what to work on next.